Hello students, in this video we have last illustration of chapter 5. The question is, a domain in ferromagnetic ion is in form of cube of side length 1 micrometer. Estimate the number of ion atoms in the domain and the maximum possible dipole moment and magnetization of the domain. To calculate these quantities, we are given that the molecular mass of ion is 55 gram per mole and the density is 7.9 gram per centimeter cube. And we are asked to assume that each ion atom has dipole moment 9.27 into 10 raised to minus 24 ampere per meter square. So, how to start? So, we know that 1 gram uh, we know that 7.9 gram is having volume 1 centimeter cube. So I would start with the volume calculation. We can say that 1 centimeter cube of iron is having 7.9 gram. What I have is 1 micrometer cube. See, we are told that the size is 1 micrometer, so volume will be 1 micrometer cube. Then how much is the mass? So we should be able to calculate mass. So let me label it as mass m, which is 7.9 into 1 micrometer cube upon 1 centimeter cube. So this will get us, let us call it result 1. So from result 1 we will have mass of the cube. Once we have mass, next we can calculate mole. So again the same logic. We know that 55 gram of iron is having 1 mole, or rather I would say 6.023 into 10 raised to 23 atoms. Then m gram will have how many atoms? So if number of atoms is n, I would say that n is equal to m into 6.023 into 10 raised to 23 divided by 55. So result 2, if I call it result 2, will give me number of atoms in the given ion cube. What next? Now we know that one atom is having 9.27 into 10 raised to minus 24 ampere meter square dipole moment, and now we know how many atoms we have, so we should be able to calculate total dipole moment. So total dipole moment is nothing but total number of atoms we have from result 2 into dipole moment of one atom, and then we have 9.27 into 10 raised to minus 24 multiplied by n. Let us label it as capital M. Okay, so result 3 will give me total dipole moment, and then if I want magnetization, we can say that magnetization is total dipole moment upon total volume. What is total dipole moment? What we calculate in result 3. What is total volume? Total volume is 1 micrometer cube. Convert it into meter cube. So substitute values, and result 4 will give you magnetization of the given cube of iron. That is all for this illustration. Thank you.